Today we're going to start with Chapter 2. And Chapter 2 is called Frequency Distributions and Graphs. We're going to be looking at the frequency distributions today. We talked a little bit about statistics, and part of statistics was describing data. And that's what we're going to be doing today. A frequency distribution is a way to summarize data so it's easier to see what's going on. So that's what we'll be looking at today, is a frequency distribution. Usually I will abbreviate these FB, so you'll see FB. A frequency distribution has two main parts. The parts of a frequency distribution are the class limits and the frequencies. The class limits have an upper and a lower class limit, and those tell you what numbers are in that group. This one here, you can see it's labeled temperatures. Every frequency distribution should have a title. A title tells you what it is. Well, temperatures, that helps some, because the number 96.5, you didn't know what it was until I told you it was a temperature. But to be complete, there really should be more than that in a title. Just that these are temperatures doesn't really narrow it down for you. Maybe I should tell you that these are temperatures from a certain clinic on a certain day. Maybe they are from Level Land Clinic. January 21st. That helps you tell more. The title should tell you everything you need to know about what these numbers are. Temperatures may not be enough, but telling you where these temperatures came from, maybe these were all the patients in Level Land Clinic on January 21st. We should have a title. Is the most important thing about any chart or graph we're going to have. Without a title, this is just a bunch of numbers. We also have our class limits. The class limits I mentioned before have an upper and a lower class limit. These tell you what's in this group. This first group is temperatures between 96.5 and 96.8, and you can see that there was one patient that had temperature in that range. 96.9 to 97.2, there were 8 people that had temperatures in that range. So you need to know how to read a frequency distribution, the class limits, and the frequencies that tell you how many is in each group. There are two important things we need to know about class limits. Class limits never overlap. Class limits never overlap. We saw here on this group we had 96.5 to 96.8, and then the next one started at 96.9 to 97.2. They don't overlap because one of them ends at this number and the other one begins over here. Overlapping would be if I had 96.5 to 96.8, and the next one was 96.8. Those would be overlapping. Those are what we refer to as overlapping. And the problem here would be you didn't know where to count somebody that had 96.8. This is wrong. This is the overlapping. Class limits never overlap. The other important thing about class limits is that class limits, when you look at the class limits, should tell you how the numbers were measured. The class limits must be to the same decimal place as the original numbers. If the class limits here are to the 10th decimal place, class limits to the 10th, you knew all of the original numbers were in tenths. Because these had a tenth here that said all of the original temperatures were recorded to the nearest tenth. We didn't have a temperature that was 97.48. If all the temperatures would have had 2 decimal places, your class limits would have to have 2 decimal places. Your class limits must look exactly like the original data as far as decimal places are concerned. So once you see a frequency distribution, you should know by looking at it what the original numbers looked like. Here we know the original numbers were all the nearest tenths. So the 2 important things to remember about class limits is they never overlap and they are in the same decimal place as the original numbers. When we look at a frequency distribution here, I said it was important to have a title. It's important to have the class limits and the frequencies. Sometimes you label these right here. The class limits, instead of saying class limits, I might have put a label across the top that said temperatures. Or I might have said in Fahrenheit, so that you know that these weren't temperatures in centigrade or Celsius, so that you knew how the temperatures were measured. You might have put a label up here. The frequencies, instead of writing frequencies, I might have written number of patients. The title and the label is important so that you can tell by looking at this all the information you need. You should not have to read a paragraph in the book to understand the chart. It should be self-explanatory. If all you look at is a chart, you should know it all. And that's the reason the title and the labels are important parts of any chart that we do. When we look at a frequency distribution, we have the class limits, we have the frequencies. There's another part we can tell here, and that's called the interval. And the interval is the distance from one class to the next class. Between 96.5 and 96.9 is 4 tenths. So the class interval this time, sometimes it's labeled with an I, the class interval this time is a 0.4. Any class you put, the distance should be 0.4. From 98.1 to 98.5, the distance is 0.4. The main thing to remember about the class interval is the interval is the distance from one class to the next class. It is not the distance here between these two numbers. It's always the distance from one class down to the next class is the class interval. Said we had some rules that class limits should never overlap. Well, another rule is the class interval should be the same all the way down. For this distribution, we could see that between each class was always a 0.4. So the class interval was the same all the way down this frequency distribution. Most frequency distributions that you see are just going to have the class limits and the frequencies. From looking at it, you can look at and pick out the class interval. But these are the parts that are given when you see a frequency distribution, the class limits and the frequencies. There are more parts to a frequency distribution that we're going to have to find. We will have to find these parts so that we can draw graphs and so that we can use some formulas. So there's some other parts to a frequency distribution that aren't always given, but are important parts. The next class we will look at is the class boundaries. Now there's a difference between class limits and class boundaries. Class boundaries, for one thing, here's the big difference. Class boundaries always overlap. You see, class limits do not overlap, so that you can tell exactly which class you are in. Class boundaries, we are going to find them and set them up so that class boundaries always overlap. Now, to find the class boundary, we find half of the distance from one upper class boundary to the next lower class. Wait a minute, I said that wrong. Half of the distance from one upper class limit, because we haven't even found the boundaries yet. Find half of the distance from one upper class limit to the next lower class limit. We subtract this value from each of the lower class limits. Subtract this value from each of the lower class limits. And we add this value to each of the upper class limits. We subtract this value from each of the lower class limits. We add this value to each of the upper class limits. Because of the way we set it up, these will always overlap. The first thing I do to find the boundaries is look over here at the limits. And what we said to do was to find the distance from one upper class to the next lower class limits. How far is it from one upper class to the next lower class? And how far is it from 96.8 to 96.9? .110. We take half of that distance. So I divide that by 2, and I get 0.05. We subtract 0.05 from each of the lower class. We add 0.05 to each of the upper class. So if I subtract 0.05 here, I get 96.45. I add 0.05, 96.85. So I have 96.45, 96.85. You subtract 0.5 all the way down here, and you add 0.5 to the upper limits. And if you notice, every one of these should overlap. 96.5, 96.5, 97.25, 97.25. If you have set these up correctly, class boundaries always overlap. Class boundaries not only overlap, they are not in the same unit of measurement as the original data. The original data was all in tenths. class boundaries are in hundreds. The class boundaries do not look the way the original numbers do, because they have one more decimal place than the original numbers do. So the class boundaries really don't look as nice and they don't make as much sense as the class limits. But we need boundaries for some graphs, and we'll need them for some formulas we're going to use later on. Now, if I were presenting this data to somebody, I wouldn't use the boundaries. I would use the class limits. That's what makes sense and is easy to read. But the class boundaries, we will have to use it for some formulas we're going to look at later on in this chapter. Now, I said one way to find the class boundaries was to look at the distance from one upper class to the next lower class. Well, that distance here was 1/10. That distance is always going to be the unit of measurement that your original datas were listed in. Here, all of your original data were in tenths, so you took 1/10 and divided by 2. If all of your original data was in ones, then the distance between here and here is 1, and you would take 1 and divide it by 2. The number that you divide by 2 is the same unit of measurement that your original data was in. Your original data was all in tenths. You took 1/10. Your original data is all in ones. You take 1 and divide it by 2. Okay, real quick on the class boundaries. The next part we need for a frequency distribution is the midpoint. The midpoint for each class is the average of the class limits. And we label midpoints with an X. We put X on top of the column, and we have the midpoints for each class. So the midpoints, we've already found the boundaries and the limits, the frequencies were given. The midpoints, you add these two numbers up, 96.5 and 96.8. You add up the limits, divide by 2, and you get 96.65. The midpoint is the average of the limits. You just add those two numbers up and divide by 2. You have to do that all the way down the column. You're going to add up 96.9, 97.2, and divide that by 2. And instead of doing this average all the way down the column, which takes a little bit of time to add them up and divide by 2, you might notice that the interval is the same between the midpoints. We said the class interval was 0.4. You can add 0.4 and get each one of your midpoints. After you find the first midpoint by adding these up and dividing by 2, you can just add the class interval. So the next one should be 97.45. After you find the first one, you can add the interval all the way down. If you notice, the interval 0.4 is the same between each limit. It's the same between each boundary. It's the same between each midpoint. Never round midpoints. When I divided by 2, it ended up with 2 decimal places. I left 2 decimal places. Even if it is different from the original class limits, you never round the midpoints. We'll be using midpoints in formulas later on, and if you round all 8 of these numbers, by the time you add that up, you'll have quite a bit of error if you round that many times. Never round midpoints. I don't count midpoints. Next part of a frequency distribution are called cumulative frequencies. We have 2 cumulative frequencies. We have a less than cumulative frequency. Less than cumulative frequency is labeled CF with an arrow pointing down. Less than, you have an arrow that points down. CF, the arrow points down. Less than cumulative frequency is labeled CF with the arrow pointing down and is found by adding the frequencies down the column. More than cumulative frequencies are labeled CF with the arrow going up. So less than goes down, more than goes up. More than cumulative frequencies are labeled CF with the arrow going up and are found by adding the frequencies up the column. Here's our frequency distribution again. We have the class limits and the frequencies. The less than cumulative frequencies, the arrow tells you how to move. You move down the column. So the cumulative says bring this number over. The first frequency is 1, you just bring that 1 over. The next frequency is 8, you add it to this one and get a 9. Cumulative means you're going to accumulate, you're going to add them up. Cumulative means you accumulate all these numbers. So you add 8 and get a 9. The next one is 14. You add 14 and get 23. You move down the column, you add each number to get the less than cumulative frequency. You add 20 to get 65, 34, 6, and 4. The arrow tells you how to move. You start at the top and move down the column. The more than cumulative frequencies go up. To go up, that says you have to start down here at the bottom. You have to start at the bottom so that you can move up. You start with the last frequency, which is 4, you write it down. As you go up the column 6, you add 6 to get a 10. You add 34, now you're at 44. You add 20, you get 64. The arrow says you move up, so you have to start at the bottom so that you can move up. Cumulative says you are accumulating. You are adding these numbers together. When you go to try to read the cumulative frequencies, the less than cumulative frequencies are read with upper class limit. The less than cumulative frequencies are red with the upper class limits. Here, if I just pick one of these numbers over here, like 23, I would say 23 of the patients had temperatures less than the upper limit. 23 patients had temperatures less than 97.6. Twenty-three patients had temperatures less than 97.6. The reason you have to read them with the upper limits is because this 23 includes everybody in all three groups, including the 14 people that had temperatures between 97.3 and 97.6. If it includes these 14 people, they might have had temperatures of 97.6. So it makes sense when you start to think about it that these 23 people had temperatures less than 97.6. So the less than are read with the upper class limits. They can also be read with the upper class boundaries. If I have the boundaries over here. But remember, less than is always with the upper. The more than cumulative frequencies are read with lower class limits. The more than cumulative frequencies are read with the lower class limits. If I pick the number 10 here, 10 patients had temperatures more than 98.9, because that's the 6 people that had temperatures in this group and the 4 people that had temperatures in here. So 10 patients had temperatures more than 98.9. Frequency distribution we're going to look at are called the relative frequencies. Relative frequencies are the percents of the total for each class. Relatives are percents. If I've got my frequencies over here, the first thing I have to do is add them up and find the total frequencies. So I just take and add these numbers up. I got 109 here, which we should have remembered. The 109 was the totals we got here on our cumulative frequency. So there were 109 total frequencies here. To find each relative, we take the frequency for that group and divide it by the total. You take 1 and divide it by 109. We want it as a percent, so we move our decimal over 2 places, and I'm going to write 0.09. Because it's a percent, when I divided 1 by 109, I got 00917. But you move your decimal over 2 places because these are always in percents. Relatives are a percent. So I've got 0.9%. Then the next one, I take the number 8 and divide it by 109. When I move my decimal over 2 places this time, I get 7.3. 14 divided by 109. 22 divided by 109. 10% of the total. This first class here, number 1, was the people that had between 96.5 and 96.8 temperatures. So there was one person that had temperature between 96.5 and 96.8, but 0.9% of the people had temperatures between 96.5 and 96.8. It simply changes these frequencies into a percent. Because these frequencies represent the entire group, this total here has got to be exactly 100%. The entire group has got to be 100%. I should add these up and get exactly 100%. So I'm going to add those numbers up and see what I get. Well, I got 99.9. I didn't get exactly 100%. That's because if you're rounding here, you're not going to get all the time exactly 100%. You might get 100.1 or 99.8. What you have to do if you don't get exactly 100% is go back and change something to make it exactly 100%. What you want to do is find a number here. Maybe you can find a number that was that was 0.34 and round it on up to a 4. Don't take a number that you already rounded up and round it up again. So I'm just going to try another number here. I'm going to try 8 divided by 109. This number right here was 07339. So I might round that up to a 4. Just pick a number somewhere and round it up 1, but don't pick a number that was already rounded up. If this number was 20.19, don't round it up again. But you can round this number up a little bit. It's called fudging. We're going to fudge just a little bit to make sure we have exactly 100% down here. We must have 100%, exactly. Sometimes if the total was 100.1, you might have had to gone back and change one of these numbers that you rounded up, change it back down a notch. But you have to make sure it's exactly 100, even if you have to change just a little bit on how you rounded somewhere. So the main parts we're going to have of a frequency distribution. I said I'm going to abbreviate it FD for frequency distribution. The main parts we have of a frequency distribution are class limits, the frequencies, class boundaries, the interval, midpoints, the two cumulatives, and the relative frequencies. These are the main parts of a frequency distribution. The red light come on? Some? Okay, last time we looked at, if you have a frequency distribution, how to find all of the parts of a frequency distribution. Well, this time we're going to look at, if you have a list of numbers, how do you go about making your own frequency distribution? Last time we were given the frequency distribution, and all you had to do was find the various parts. Well, now if you have a list of a bunch of numbers, and all these numbers are just a big jumble of numbers, how do you go about making your own frequency distribution? The first thing we need here are some guidelines or some rules for making your own frequency distribution. These are some rules for frequency distributions I want you to follow in any frequency distribution you make in here. The first one says the class intervals should be equal. That's the distance from one class to the next class should be equal all the way down your chart. You should have the same distance all the way down. Class intervals should be equal. The next rule is kind of general here, but it says that there should be between 5 and 15 classes. That's a pretty big spread here, but one thing you want to watch is that you don't have too small. If you have a group that's too small, if you just have two groups in it, that really doesn't tell you what's happening with the set of numbers. So you want between 5 and 15 classes. That's pretty general. Avoid overlapping classes. Remember that the class limits should not overlap. Avoid open-ended classes. Open-ended class would be like if your last class said from 100 up, and you don't know if your biggest number is 200 or 2,000. That's open-ended. And you should have no empty class. An empty class means that your frequency is 0. Okay, those rules, first I said the class intervals should be equal. Now here's an example of a wrong one. You should not go a distance of 6, a distance of 6, distance of 15. You should have the same interval all the way down. So there's an example of something that is wrong. Here's something else that is wrong. If these are your class limits, they should not be overlapping. 20 to 25, 25 to 30. This is wrong because you should not overlap. The wrong thing about this one is if you had a number 25, which group would you count the 25 in? Now remember, the boundaries always overlap. The limits should not overlap. An open-ended class is it like your last one says 100 up. You don't know if your largest number is 200 or 2,000. This is open-ended. And another thing that could be wrong is if your frequency's over here, you should not have an empty class. Sometimes that empty class is at the very top or the very bottom. If you have an empty class down here at the bottom, that just means you should not have even have listed this last one. You didn't need it. But if the empty class is in the middle, you may have to adjust your interval so that you do not have an empty class. There should be at least one frequency in every class. Now this is the one rule here on those rules I gave you that sometimes you have to break. Sometimes you have to have an empty class. You will get a set of numbers sometimes that has one number so large down here at the end that you're going to have a group here with a 0 and in another group just to get this one large number that's so much larger than the others. So sometimes you have to, there's no way around it. But you try to make sure you don't have an empty class. When we go to make a frequency distribution, there are advantages and disadvantages to a frequency distribution. The advantages are that it's easy to read. It's easier to read than a whole list of numbers. If you have a list of 100 numbers and they're in no particular order, it is sometimes hard just to pick out what the largest number and the smallest number is. It takes a little bit of time just to go through there and pick out the largest and the smallest. Well, on a frequency distribution, it is easy to pick out your largest and your smallest. This one we worked with earlier, it's easier to see that the smallest temperature was 96.5 and the largest temperature was 99.6. So if you had all of these 100 temperatures all listed in no particular order, it would even be hard to see the largest and the smallest. So it makes it easier to pick out things. It also makes it easier to pick out that most of the numbers were somewhere between 97 and 98. It helps you see a pattern to the numbers. It makes it a lot easier to tell what's going on here than just a big old jumble of numbers. A big jumble of numbers is hard to tell what's going on. So it is easier to read. It's easier for you to summarize the data. But the main disadvantage of a frequency distribution, the main disadvantage is that you lose the exact data. When you have the numbers, you knew the exact numbers. But when I then give you a frequency distribution, all you know is that one temperature was between 96.5 and 96.8. You don't know if that number was a 96.7 or a 96.8. You lose the exact numbers. You know these 8 numbers were in between here, but you don't know what they were. So you do lose some exactness, but it does make it so much easier to read and tell what's going on that we use them a lot, even at the risk of losing the exact numbers. Okay, we have our rules for frequency distributions. Now the steps to make a frequency distribution. If you want to make a frequency distribution, and all you have is a big long list of numbers. The first thing you do is find the class interval. How far do you want from one group to the other? The formula for the class interval is the highest number minus the lowest number. The highest number minus the lowest number over 1 plus the number 3.322 times the log of the number of frequencies. This formula is not in your book, so I want to make sure that you get this one down. The highest number minus the lowest number. 1 plus 3.322 times the log of the number of frequencies. How many numbers do you have? Do you have 100 numbers in your list? Do you have 200 numbers in your list? That's what this number is. How many numbers do you have? To work this formula, you might want to write it down with parentheses. When you punch things in your calculator, you have to tell it what order of operations to do. You have to tell it to do the subtraction first, so you put a parentheses. Then you have to tell it to do all of the work in the denominator before you do the division. So on your calculator, you would punch in the parentheses. You would punch in the highest number. You'd hit a subtract, the lowest number. Close your parentheses, and then hit a division sign. You would do all of the numerator inside parentheses, hit a division sign, do another parentheses, 1 plus 3.322 times, you would end the number of frequencies, hit the log button, then close it. Then finally hit equal. You'll have to play with your calculator till you're used to using your calculator and used to using these parentheses. We will use a lot of formulas in this class where you have to know where to insert the parentheses for your calculator to do the operations correctly. If you did not insert the parentheses on this problem, your calculator would say high minus low, and then if you divided it by 1, they would go ahead and just divide by 1 and then do the addition. You have to tell your calculator how you want it to do the order of operations. Now down here where I put the number and then the log, if you have graphing calculators, you will hit the log button and do the number. These two will be just the opposite if you have the graphing calculators. All the other calculators, this is how you'd hit it in. So this formula gives you a figure for your interval. You should always round this number up. The interval should be in the same unit of measurement as your original numbers. If your original numbers are in the 10th, round your interval to the 10th. If your original numbers are rounded to the whole number, put your interval as a whole number. The interval should be the same unit as measure as your original numbers, whether in the ones, the tenths, the hundredths. That's what your interval should be. Okay, once you know what your interval is going to be, that's going to be the first step. You have to find the interval first. Then you must find your first lower class limit. Your first lower class limit should be the smallest number, or a little smaller. If your smallest number is 21, maybe you're going to use 20, just because you think it looks a little prettier to have 20 instead of 21. So use your smallest number or a little bit lower. If your smallest number was 19, you couldn't use 20 because you wouldn't have a group to put the 19. You must make sure that it's your smallest number or lower. Now the book says to use a multiple of the interval. Don't worry about that. It says if your interval is 5, use 5, 10, 15, or 20. That makes things look pretty, but it's not always possible. So don't worry about using a multiple of the interval. That's just what it says in the book, but don't worry about it. Find the first lower class interval. If my smallest number was 21 and I decided to use 20. Now, find the rest of the lower limits by adding the interval. We don't do the first class, we do all the lower limits. So if my limit is 20 and my interval is 5, I'd go 25, 30, 35. You find all of the lower class limits first. Find the rest of the lower class limits by adding the interval. So keep adding the interval until you get a number that is larger than your biggest number. Once you get bigger than your biggest number, you can stop. You don't need that class. Now find the first upper class limit. If your numbers are rounded to 1, if I'm going down here and it's 20, 25, 30, if all of my numbers are in 1, you want to be 1 away here and make it 24. If my round numbers were to the nearest 10th, I would have to be a 10th away from here and be 24.9. You want the unit of measurement to be the same between this one, the upper, and the next lower. The rounded in tenths, you want to be 1/10 away. If the numbers are rounded to 1, you want to be 1 away. And then, to find the rest of the uppers, you add the interval again. Find the rest of the uppers by finding the interval. Now these rules will make more sense when I go back and do a problem. The next one is to do the frequencies by a tally. You come over here and say, well, I have a 21, it goes in this group. I have a 25, it goes in this group. You just make a little mark for all of your frequencies, and then you count up how many are in each group. Do a tally to find the frequencies. Then we fill in all the rest of the pieces. The midpoints, the boundaries, the cumulatives, the relatives. Then you find the midpoints, boundaries, relatives, and the cumulatives. They say true class limits, that's what we call the boundaries. The midpoints, the boundaries, the relatives, remember the relatives are the percents, and both cumulatives. Then you just fill in all the pieces. Like I said, some of these don't make a lot of sense. They'll be a lot clearer once we actually do a frequency distribution. These numbers I have here are a list of numbers for rent for one-bedroom apartments. These numbers are in your student study guide on page 13. They're an example there in the student study guide if you want to look in the student study guide. So these numbers are the rent for one-bedroom apartments. I'll give you just a second to copy these numbers down. But like I said, they are on page 13 of your student study guide. first step to making your frequency distribution has got to be to find the interval. What do you want your interval to be? The formula I gave you for the interval said to find the interval, you take the highest number minus the lowest number. So look through these groups, and what is the largest number there? 325 is the largest. What is the smallest? Okay. So this formula says to take 325 minus 180. Then it says 1 plus 3.322 times the log of the number of values. So I need to know how many values I have. There's 20 numbers. Now, if you want to, when you write down a formula like this, you might want to go ahead and put in the parentheses to tell you how to punch it in. If you don't punch in parentheses, if you punch it in just like you said, 325 minus 180 divided by 1, your calculator will divide by 1 and then do the addition. So you must tell it what you want it to do. You want it to do this subtraction. You want it to add all of these numbers up, then divide. So punch it in your calculator as parentheses 325 minus 180, close parentheses, divide. Parentheses 1 plus 3.322 times 20 log, close parentheses. Now try that on your calculator to make sure you know how your calculator, but make sure if you have a graphing calculator, these two are reversed. If you have the TIs, the TI 81, 82, these two numbers have to be reversed. You hit the log first. Is that what somebody got? I didn't write it down. Make sure you hit an equal here at the end, or it's not going to complete the operation. Make sure you put an equal. Now the rule of this formula says always round up. Even if this is just a 2, you round up to 28. Round up is not the same thing as round off. Round off says if it's less than 5, you drop it. 5 or more, you add. Round up says you always go up no matter what you have there on the end. So I use a class interval of 28. This formula gives you a ballpark figure. If you want to use 28, use 28. If you think it would be a little bit prettier to use 30, you can use 30. This is not the only correct answer. This is not the exact number you have to use. It just gives you a number that you should be in that area. Now 28 might give you like the best picture, but 30 might be just as good. So a lot of times we use an interval that we consider to be a little bit prettier number, like 25 or 30. But I'm going to use 30. Now, like I said, this is not an exact number. You do not have to use exactly 28. That gives you an area to start with. I am going to use 30 just because I think 30 is a little bit easier to work with a round number. But you may use 30, somebody else may use 28. There is not just one correct answer. There are many answers that would be just as good for this particular problem. Now, don't worry about it, but I'm going to mention in just a minute that this is not the formula the book uses. The book uses a formula that says high minus low divided by the number of classes. But to use the book's formula, you have to decide whether you want 5 or 6 or 7 or 10 groups. How many groups do you want down there? Well, that's part of this, is knowing, well, what is the best group? Well, you don't have to know what is the best number of classes if you use this formula right here. This formula is called Sturge's formula. And it means you don't have to make a decision. You don't have to decide whether I want 7 groups or 10 groups. And that's the nice thing about Sturge's formula over the one in the book. And that's the reason I don't use the one in the book. In the book, you have to decide how many groups you want. Using Sturge's formula, you don't have to decide that. So, if I decided to use 30, the smallest number here was 180. I could start with 180, or I could start with something a little bit smaller. If instead of 30 I was using 25, I might want to use 175, because when I add 25 I get 200, I get nice pretty numbers that way. You start with the smallest number or a little bit smaller. So I'm going to start with 180, my interval is 30, so I don't worry about the upper limits yet, I just add 30 all the way down. Now what was my largest number? My largest number was 325, so as soon as I get bigger than that, I can quit. Because I don't need a group that starts at 330 if my smallest number is 325. You just add 30 all the way down till you get past your biggest number. Well, I can see here that this is going to give me 5 groups. But I didn't have to decide on 5. The formula got me 5. Now, to figure out my upper limit here, I have to go back to the numbers and see if those numbers are in ones, rounded off to the nearest hundred, rounded off to the nearest tenth. Well, all of these are numbers I started off with, which are the nearest 1, a 5. Well, actually, these have all been rounded off to the nearest 5, haven't they? They've all been rounded off to 5. If they've all been rounded off to, I'm still going to use the ones place. You either look at a decimal place, either the ones place or the tenth or the hundreds or the decimal place. So if these have all been rounded off to the ones, then I subtract 1 to get 209. The distance from here to here is the same as the unit of measurement used in my original numbers. If my original numbers were $325.76, if my rent was listed to the nearest cent, I would have to have and this would be 210, I would have to go 1 penny away. To round it off to the nearest penny, if my numbers were to the nearest penny, this has to be 1 penny away. So I can tell from looking at this right here that my original numbers were all rounded off to the ones place. Now, because my interval is 30, I can add 30 all the way down. And now I have my class limit. Now what I need to know is how many is in each group. And here's what we call a tally. I look at each number. The first number on my list was 200. 200 goes in this group. I just put a little mark here. The next number on my list was 290. A little mark in this group. 180. 235. This is the boring part. It takes a little time, but you just put a mark for each group. 185. 250. 225. 245. 325. 285. 210. 205. 320. 190. Told you this was boring, didn't I? 225. 230. 310. 290. 235. And 260. Now the tally marks are not part of your original, not part of your answer. They're just what you have to do. So now I can make a little bit nicer looking. And I can see that my frequencies then were 5. Looking here at my tally marks. 6, 3, 3, 3. And that should add up to 20 if I had 20 numbers to begin with. Now I can come over here and I can write down my boundaries. The distance between here and here is 1. So half of that is 0.5. I subtract 0.5. 179.5. Subtract 0.5 all the way down. Add 0.5 all the way down this column. Two ways to check the boundaries. First of all, make sure they overlap. 209.5 to 209.5. 239.5. 239.5. Make sure your boundaries overlap. Make sure the interval is the same all the way down your boundaries. These are all 30 because my interval is 30. Midpoints. 180 plus 209 divided by 2. My midpoint, 194.5. Do not round that off to 195. Never round a midpoint. Now I can do that again or just keep adding 30. That's 314.5. Midpoints are always labeled X. My two cumulatives. The less than cumulative, the arrow goes down. Less than cumulative, I start with the 5, add 6, add 3, and I get these numbers right here. Yeah, these numbers. These were over here where I did a tally. And what I did was I said that the first number was 200, so I put a mark in this group. And then the next group was 290. After I did my tally, these were 5 numbers, and that's where I got my frequency of 5. But these were just little marks to tell me how many were in that group. There was 5 in this group, 6 in this group. But these tally marks are where I got that. That answer your question? Here we had 2 cumulatives, 1 cumulative that was the less than cumulative. Now we have a more than cumulative. We start at the bottom this time. To be able to move up, you have to start at the bottom. 3, 6, 9. And the relatives. One thing about the relatives, make sure you don't look at one of these cumulatives. Make sure you go back to the original frequencies when you're doing the relatives. And you take 5 divided by 20. 5 divided by 20 is what? 25%. 6 divided by 20. 3 divided by 20. And that should total up to exactly 100. Now, if we've followed all of our rules, we should have a correct frequency distribution. We should not have an empty class. We should not have anything that overlaps. Now sometimes, once you use Sturge's formula and you decide upon the interval, you might end up with an empty class over here. If you ended up, when you counted those tallies, and you ended up with an empty class, you need to go back and change these numbers here. I had rounded 27 up to 30. If I had an empty class, I may have to go back and try 27. I might have to go back and try 35. You may have to go back and adjust the interval to get rid of the empty class. Instead of 180, you might have to start at 177. You might have to go back and change some of these to get rid of the 0 frequency, if you have one. So you may have to redo this 2 or 3 times if you have a 0 there to get rid of that 0. There will be some times when there is no way to get rid of that 0 and you just have to leave it there. The only way to get rid of the 0 might have been to have 3 big groups. We don't want less than 5 groups. You might have to have a 0. But you always try to get rid of that 0 if you can. And another thing to remember about this is not the only correct answer. This is one correct answer, but somebody else may have picked a different number to start with. They might have used 27 instead of 30. This is not the only correct answer. There is not just one correct answer here. Any questions on making your own frequency distribution? The first upper class number here. Oh, this one here. Okay, once I had all of these numbers, by picking my smallest number and adding my interval, I looked back to my original numbers and saw that my original numbers were all rounded to the ones position. If these all would have been zeros, then all of the numbers would have been to the tens. But since there was a number here, all of these numbers were rounded to the nearest 1. They were rounded to the nearest 1. I subtract 1 from here to make it 2 on 9. If my numbers are rounded off to the nearest tens, if my original numbers are 110, 120, 130, when I go down here, If these numbers are in tens, I would take 10 from this number and go to 140. Okay. My original numbers are all to the nearest tenth. And I would have 10.0 to 12.0. Then what would you take away here if my original numbers were a 10? It'd be 11.9. You take away a tenth. It's whatever these numbers are rounded to, that's how much you subtract from here to here to get the first upper. Okay? Is that clear? We're going to look now at the graphs of the frequency distribution. We have different graphs that are used to show a frequency distribution. And graphs, again, are used to make data more easy to understand. Look at it and get a complete better picture than a graph if you do just a list of numbers. The graphs we make of the frequency distribution are listed on the handout. The first graph you see is called a histogram. A histogram is a bar graph using the data from a frequency distribution. A bar graph, and it says in the handout that a bar graph that labels boundaries along the bottom. The boundaries are actually labeled along the bottom. This is the reason we need to know all of those different parts of the frequency distribution so that we can make these graphs. The boundaries are labeled along the bottom, and you graph the frequencies of the side. When you make a histogram, the bars touch. I'll go over all of these types of graphs, and then we'll make some of these graphs. Besides the histogram, the next one is called a frequency polygon. A frequency polygon is a line graph that labels the midpoints along the bottom and graphs the frequencies of the side. It's a line graph. You have to use the midpoints. The ogives, there are actually two ogives, and the ogives use the cumulative frequencies. Ogives is again a line graph. We have a less than ogive and a more than ogive. Remember, less than cumulative frequencies, we label arrow going down. And these are the cumulative frequencies we got by adding the frequencies down the column. So the less than cumulative frequencies are graphed in a less than ogive. They label the upper boundaries along the bottom. When we read the cumulative frequencies, the less than will label the upper boundaries. So we label the upper boundaries along the bottom and graph the less than cumulative frequencies. The more than ogive labels the lower boundaries. The more than ogive labels lower boundaries along the bottom and graphs the more than I should put that change on the handout. The more than labels lower boundaries. Then a pie graph is a graph of the relative frequencies. A pie graph is a circle graph, and a circle graph always uses whether it's a frequency distribution or not. Pie graphs are always yours. So I'm going to make some of these graphs now, and the frequency distribution that I'm going to use is in the student study guide on page 17. Copy out of your student study guide, and I'll write the frequency distribution right here. are the college professors. Now the labels, this doesn't tell you anything, it's just a bunch of numbers. So now you know that 16 professors have between 0 and 4 years of teaching experience. 10 professors in this particular group, 10 professors have between 20 and 20 years of teaching experience. So now that you know what these numbers mean and what they stand for, what if I told you about it? A title might be something if I told you what college this came from. If I told you that these were South Plains College professors, that would be the title of this group, so you would know what group of people this represents. The first talk for the day is the histogram. Histogram is something that uses the boundaries, and to label the boundaries along the bottom. So these are the class limits. I have to find the boundaries. To find the boundaries, the first thing I have to do is see how far it is from this other limit to the next other limit. This boundary distance is 1. That means, looking at all of these numbers, you can tell that the original numbers were rounded off to the nearest 1. None of the original numbers were 2.5 or 8.7. If there are no decimals in here, there were no decimals in the original numbers. So all the original numbers were rounded off to the nearest 1. The difference between here and here is 1. You take 1 divided by 2 is 0.5. Subtract 0.5 down this column. Subtract 0.5, you get 0.5, 4.5, 9.5. Subtract 0.5 all the way down to the lower limit. Talk about this last column of parts of the frequency distribution. We subtract 0.5 down the lower limits. We add 0.5 down the upper limits. So now I'm going to add 0.5. We mentioned last time in class limits never overlap. It goes from 29 to 30. There's a distinct difference here. But boundaries always overlap. So one way to check it is to make sure these are overlapping. The other way to check it is the interval is 5. 5 is the distance between each class. 5 should be the difference between each class over here. So always check your boundaries so that they overlap. And the interval is the same all the way down. I know your boundaries are correct. So now we're going to make the histogram. And it says the histogram labels the boundaries along the bottom. So I'm going to start with my bottom line here, and I'm going to label the boundaries. The boundaries start with negative 0.5, 4.5. Now I should keep the same space here. Make sure you're having the same space along here. And the next boundary is 4.5 to 9.5. Keep the same space. Make sure you have equal spaces between the marks. And you actually label the boundaries. Don't label it 5, 10, and then say if I label it 5 and 10, graph 4.5 here. Don't do that. Make sure that the boundaries are the numbers that are written along the bottom. That's why this is pretty good. So this is the boundary along the bottom. You must write those numbers. Then up the side of the graph, the frequencies. The frequencies go all the way to 20. We have to make sure to mark up the 20. Each line are 5, 10, 15, 20. 3.5 and 4.5. This is the bar labeled on the bottom. The frequency is 16. So this bar has to go up to 16. Now, notice the difference on the direction. I said it labels the boundaries, but it graphs the frequencies. The boundaries are actually written along the bottom. But the frequencies don't have to actually be written. 16 doesn't have to be written here. You just bracket up to 16. The boundaries have to be written, but you just bracket up to 16 on the frequency. Now the next goes from 4.5 to 9.5, and its frequency is 21. That's the reason the bars overlap. The bars touch here because the boundaries overlap. So this one ends at 4.5, the next bar begins at 4.5. The bars touch because the boundaries overlap here. The next range is 9.5 to 14.5, and the frequency is 12. And 14.5 to 19.5, and the frequency is 11. Now, the only thing missing is we must have a title and a label, or we don't know what this is. Again, if that's all we have, we don't understand what we're looking at. These numbers along here represent years of experience, or years of teaching experience. Years of teaching experience. And the numbers along the side here, this 16 represented how many college professors have this experience. So this represents the number of college professors. Later, look at this in text, without referring back to anything else. This is how many college professors have this much experience. 21 college professors have this much experience. Now, history is not actually a title. A title should be something like where these numbers came from. Are these numbers from a certain college or from a certain year? That's what you put under the title. The name of the college, or maybe this was 1995. Name of the college. Any pertinent information about where this data came from will be on the title. You're going to have a history. And the next one I'm going to look at is the frequency polygon. The frequency polygon was a line graph. It's a line graph, and it says that it labels two midpoints. The line graph separates the midpoints. So I have to find the midpoints. Remember, the midpoints were always labeled X. X is what we use when we see after the label for a frequency distribution or a formula below the midpoint. The midpoints we find by adding the upper and lower and dividing by 2. The upper and lower class limits and divided by 2. 0 plus 4 divided by 2 gives me. That down here, 5 plus 9 is 14, divided by 2 is 7. The midpoint is the average of the upper and lower class limit. Another way, after you've found one class limit, is to remember that the interval is 5. The interval has to be 5 between each midpoint. So I can just add 5 and get each midpoint after I find the first midpoint. get midpoint and just put a mark instead. You always write the actual midpoint for long one. Another thing about frequency calling, you need to call one mark to the left and one mark to the right. We need an extra mark to the left and to the right before we start laughing. Then we're going to mark at the side, and again it simply graphs the frequencies of the side. The frequencies went to 20, so in our Bible, it went to 21. So I would go 5, 10, 15. To do a line graph, you start by putting a point at each one of these. The midpoint of 2, their frequency is 16. 2 had a frequency of 16. 2, we go up here to 16, make the mark. 7, had a frequency of 21. 12, frequency of 12. 11. 7 years of experience. It's not the law because it is a true statement, but mainly it's because of books that we draw it back to the Bible. You do not have to label these arrangements. The thing to remember about these parts is they are a full space away. Don't just drop this anywhere you want to. You go a full space and drop it. Again, just don't drop it anywhere you want to. You go a full space and drop it. You can't label them. You don't have to do label them. They have to be the same distance as these others. Do not put a zero here. It has to be a 5 distance from here. Now, again, we have to label this. If this was years of teaching experience, this was doubling professors. Across the top, again, you would either write the name of the college or the year, or if this was a sample of a lot of experience out there around the West Center, but you tell at a quick glance that most of the teachers had less than 12 years of experience. You all have between here, but very few had over 22 years of experience. At a quick glance, you can tell where most of the teachers and how many experience they have. It allows it to make it quick and easy for you to interpret the data and that's the benefit of a picture over just the long list of numbers. At a quick glance, you should be able to tell nobody had more than 37 years of experience, but most of them had anywhere between or less than 12 years of experience. We summarize the data and that's quick and easy to see what's going on. The next graph we're going to look at are the OGIs. And the OGIs, use your cumulative frequency. So we get two cumulative frequencies. The less than cumulative frequency is written with an arrow pointing down. The more than cumulative frequency is written with an arrow going up. Those arrows tell you how to add the frequency. The arrow pointing down says that you move down the column. Back over here to the frequency, line 16. Cumulative says we're going to accumulate. So you're going to add 16. I'm going to add 21 to 16. Add 12. Add 11. Add 10. Add 8. Cumulative frequencies, the less than moves down. The arrow going up says you have to move up the column. And to move up, you have to start at the bottom. So you write down to 2. You're going to add 8. Add 10. Add 11. Add 12. 21. And 16. Arrows tell you how to move up or down the column and add up the frequencies. Then the less than OGI. So right here are the less than cumulative frequencies. The less than are graphed with the upper boundaries. Less than are graphed with upper boundaries. Because you can say that 49 of the professors had less than 14.5 years of teaching experience. It must be the upper boundary because these people that had from 10 to 14 are included in that number. So 49 had less than 14.5 years of experience. These are the numbers you put along the bottom. Again, we start by leaving one blank mark. Leave a blank mark and then start with 4.5, 9.5, 14.5. All of the upper boundaries. This time when I mark the frequency this time will all the way up to 80. Now there's not a definite rule to mark up this side. You might mark it 10, 20, 30. You might mark it 20, 40, 60, 80. Wherever you mark it, just make sure that there is the same distance between each mark. The first one, the 4.5 on the boundary, goes with 16. So 4.5, 16. The 9.5, 37. Next one is 49. This time we'll start over here at the bottom and we connect the dots. This graph starts at the bottom, but we do not drop it down to the bottom. It starts at the bottom because we are reading this less than, and 6 professors have less than 4.5 years of experience. But you can't drop it to the bottom over here and say that 0 professors have less than 39.5 experience. So it does not make a true statement if you drop this one to the bottom. So think of this as going uphill all the way and you never drop it back down. You start over here, but you not drop it back down. If you label this, you might have to, but if you label this one, it must be exactly 5 away. It has to be a negative 5. You don't have to label that one, but if you do, it must be exactly 5 away like all the other ones. And this says 0 teachers have less than 0 teaching experience. It's true on this end to have a 0. It is not true on this end to have a 0. Again, we label years of teaching experience here. But over here on this side, we must label this cumulative number of professors. We must know this is a cumulative number so that we don't think that 39 professors have this. 39 professors have less than this. We can also somewhere in the title put the word less than. We can call this a less than graph, a less than ogive. We need the word less than so that anybody reading this can read it as 60 professors had less than 19.5 years of experience. If you don't put the word less than, they're going to read it as 60 professors had this many years of experience. And then 6 professors had less than 19.5. Again, you put the rest of the title, you put the college, you put the year, but you must have the word less than, you must have cumulative over here, so that you recognize the difference between this one and the frequency column. You must have the word less than there. The more than ogive. More than ogive, we're going to label the lower boundaries. That's why we have out, we should say label lower boundaries up on the bottom. The lower boundaries the more than uses the cumulative when we add it up, but this time the more than uses lower boundaries. So this time I'm going to start with the negative 0.5. And I go 4.5, 9.5. Then the lower boundaries, the last one is 29.5. So you label first all of the lower boundaries. what 20% of 360 degrees was. You take 20% of 360 degrees and mark off that degrees with a protractor. We're not going to be that exact. We're just going to make a close enough picture. First, by making a circle. And you can use a glass or a Coke can. You have to make a circle when you're doing something else. Just draw a circle. Now, what we're going to do is start with a mark at the top and a mark at the bottom. That already divides your circle up in half. Then we're going to mark a mark over here and a mark over here. Just eyeball as close as you can, and you divide the circle into 4 equal parts. Because we're not thinking in degrees, I'm not thinking of this as 90 degrees. I'm thinking of it as a piece of pie, and the whole pie is 100%. I'm going to start up here at the top with a 0%. If this is 1/4 of the way around the circle, what would 1/4 be? 5%. And 1/2 of the way around the circle is 50%. 75%. When you make it back to the top, you get back to 100% of the circle. Now, I'm going to make some more marks in here by just eyeballing it as close as we can and put 4 more marks in between here. Just make it evenly as you can. And now what you have is 5, 10, 15, 20, 45%. Just exact, just as close as you can by looking at it. Put 4 equal marks in between each one of those big marks. And then this would be 30, 35, 40, 45, 50. This is a quick and simple way to do a pie chart without having to use a protractor and marking everything off the back. Then we're going to start with the circle and draw a line up here to 0%. Our first piece of the pie is 20%. So I count 5, 10, 15, 20. And this piece of the pie is 20%. To label a pie chart, we always put the percent in here. And we use the class limits. Percent and the class limits. You just put 20% and then I can tell you anything. But now we put 0 to 4. And we now know that 20% had 0 to 4 teaching experience. Now the next one is 26. I don't want to mark it off at 26. What I want to do is start at this point and count 26 so that I have a second piece that is 26. Well, sometimes instead of counting 26, it is easier to write your cumulative percents. You do your cumulative percents, that'll tell you where to make each one belong here. Cumulative percents start with the 20, adds 26, adds 15, 14, 13, 6%. Don't label it 46. 46 just helps you decide where to place the mark. 26% have how many years of experience? 5 to 9. The next mark is over here at 61. Sorry, no, 50, 55, 60. This is where you mark. This is what you label. This piece of the pie is only 15% of the pie. And it was 10 to 14 years of experience. time